Hi everybody, today we're making a video on our Reynolds number experiment. I'm Ronald Mauser.
I'm John Rice.
And I'm Shawn Nguyen.
So on the left you can see the constants that we used for our calculations. We found rho and mu online for properties of water table, and then we took the diameter of our tubing and we used that to calculate the cross-sectional area that the water is flowing through.
Then on the right side, you can see Q, which is the flow rate. We calculated that by taking the volume and dividing that by the time in seconds. And then you can also see our velocity calculations, which is the flow rate over area, as well as the Reynolds number calculations, which are rho times the velocity times the diameter all over mu. The materials that we used a black food coloring. This was to help get the water in the reservoir as dark as possible. That way we could see it passing through our nozzle. We used a 1/2-inch clear piping and a 3D printed nozzle. It's printed with PLA. We used 1/2-inch valves, 1-inch angle aluminum to help hold our piping, a large storage bin, a smaller storage bin, which served as a reservoir, flex tape, JB weld, and liquid silicone. So in this picture right here, you'll see our experiment. So you can see the black fluid, which is just black water in the reservoir, mounted up above, dripping straight down, gravity fed, into the nozzle where it's able to be pushed through the pipe. And then right here, you're able to see how the exit pipe is actually attached to the larger box. It's attached with JB weld. It's a very quick drying JB weld. And then you can see the exit valve, which we opened and closed to help control whether it was going to be laminar, transitional, or turbulent flow that we were able to see from the injected fluid.
So, John mentioned earlier about laminar, turbulent, and transitional flow. But what are they? Well, you have this thing known as the Reynolds number, and that kind of determines what kind of flow you have. So below 2100, you have laminar. Between 2100 and 4000, you have transitional. And above 4000 is turbulent. So what are some of the easiest ways to characterize it instead of having to do math? Well, if you look at the pipe and you look at the dye, if let's say the dye is flowing in a straight line where it's very smooth, you have laminar flow. Simple as that. Now, once when you start having, well, the smoothness starts to turn a little turbulent where it's forming these eddies or these curves, you start having what's known as transitional flow. And as stated before, that's in between 2100 and 4000. Pretty easy, right? And then above 4000, well, you have turbulent flow, which I don't think I need to explain what it is because it's literally just chaotic. You have eddies everywhere, a lot of swirling, high flow rate, etc., etc. Now, enough of these explanations. Let's see the results. So, Ronnie, can you take it away?
And here you can see our laminar flow calculations for our first experiment. We calculated the volume flow rate by filling up the 2-liter bottle and measuring the time in seconds. It took 1,034 seconds to fill up the 2-liter bottle, so the water was moving very slow at 0.0153 meters per second for its velocity, and that gave us a Reynolds number of 193.3, which is very low. It's very in the laminar flow range. We redid that experiment again after closing the valve and reopening it until we got laminar flow, and this time it took 1,058 seconds to fill up the 2-liter container, which gave us a very slow velocity of 0.0149 meters per second. That gave us a Reynolds number for the laminar flow of 188.9, which once again is well below 2000. Now for the transitional flow calculations, in the video that you just saw, it took 76 seconds to fill up a 2-liter container. That gave us a considerably faster but still pretty slow velocity of 0.2 meters per second, which gave us a Reynolds number of 2,629, which is in the transitional flow range between 2,000 and 4,000-ish. Now onto the turbulent flow calculations. This water is moving much faster. It took 45 seconds to fill up the 2-liter container this time, which gave us a velocity of 0.35 meters per second and a Reynolds number of 4,440. And that is above 4,000, which shows turbulent flow. And then we reran this experiment. This time, we opened up the valve even more. It took 40 seconds to fill up the container, which gave us a velocity of 0.39 meters per second and a Reynolds number of 4,995, and that is well above the turbulent flow range.